Hi guys, welcome. Today we're looking at week 2 of the second semester. So we're going to be covering lessons 83 through 85 this entire week. Again, not in one day, but the entire week. All right, so lesson 83, we are looking at proportions. Okay, so proportions are things that are going to be equivalent, but we can reduce it down to price per unit or whatever. It's going to be proportional. So if I have something and I double it, the size, well, it's still proportional to the original. Okay, so something is proportional. Proportion is a true statement that two ratios are equal. Here's an example. So 3/4 equals 6/8. 6/8 would reduce down to 3/4. So these two are equal. So we doubled it, and we doubled the numerator and the denominator, but it's still equal to 3/4. So which ratio forms or fraction forms a proportion with 2/3, not 2/4, not 3/4. I multiply top and bottom by 2, I get 4/6. So C is the correct answer. Okay, we can also use it as ratios or comparisons. 4 is to 6, so 4/6, as 6 is to 9. Okay. So 4 times 1.5 or 1.5 equals 6. Same thing, 6 times the same number equals 9. So we could reduce these down. This would reduce down to 2/3. This would also reduce down to 2/3, so they're equal. Okay, we can use this to solve unknowns. Let's say we have an unknown in the numerator or denominator. We know they're equal. We can cross multiply and divide. Sometimes we can look at and see, well, 3 times 2 is 6, so 5 times 2 equals 10. Sometimes it's simple and we can just kind of visualize that. Other times we're going to use cross multiplication and division, which I know we've done. So 3/5 equals 6/a. So there's two methods. We can say, well, I know I have to multiply the numerator and denominator by the same thing because 2/2 is equal to 1. It's saying it's equal, so it's going to have to be equal. So I get a equals 10. 3 times 2 is 6, 5 times 2 is 10. Okay, another way we can do it, which down the road I think is going to be better because it's not always going to be, oh, I just multiplied this by 2. Sometimes we may have a decimal number here and a decimal number here, and trying to figure out what we multiplied by is going to take you forever. You can always cross multiply and divide. Okay, so 5 times 6, 3 times a, divide, and a equals 10. So two different ways we can solve it. I prefer the cross multiplication and division just because that'll always work out and be nice and neat. Sometimes, especially early on here in some of these examples, you won't need to do that. You may just be able to see, oh, we multiplied 3 times 2, so I have to multiply the denominator by 2 as well. Gives me 10. No problem, that's fine. When I said cross multiplication and division, I wanted to show you what I meant by that. So this one, if I have 2/6 equals n/30, okay, well, I can cross multiply and get 6n equals 60, divide both sides by 6, or I can say, well, 6 times 5 equals 30. So 2, if these two are equal, I have to multiply 2 by 5 as well to give me 10. Okay, so I just want to show so you know both methods. Down the road, it will kind of become like some other things we've talked about, your personal preference on which one you want to use. I prefer, as we get further into it, cross multiplication and division. Just as you'll see, we'll see some examples that are not easy to be like, oh, we multiplied by 2 or we multiplied by 5. But for right now, this method is perfectly fine. Okay. Lesson 84, order of operations, part 2. So we've already worked with order of operations. We know parentheses, please excuse my dear Aunt Sally, or PEMDAS or GEMDAS, grouping symbols, parentheses. We know it's more than parentheses, so that's where grouping symbols, numerator, denominator, brackets, braces, parentheses, even absolute value. So those are all grouped symbols. And then exponents or roots. So if I square something or take the square root or cube or take the cube root, which we haven't seen a lot of that, but that will come after parentheses or grouping symbols. Multiplication and division, those have the same priority. Just because our jingle says multiplication and division doesn't mean multiplication has a higher priority than division. It's the same priority. So if you have an equation with a bunch of multiplication and division, which one do I do first? Well, they're the same priority, so you work left to right. Okay? And then addition and subtraction, same priority, so same concept. Left to right. So whatever jingle or acronym or thing you need to know to remember. This one doesn't include exponents just because we haven't talked a lot about that, which is fine, but we'll see those down the road. So I have 2 times 8 plus 2 times 6, which I don't just work left to right because I have multiplication, addition, and multiplication. So I have to multiply, and then I add. 2 times 8 is 16. 2 times 6 is 12. So 16 plus 12 is 28. If you're doing it in your calculator, just be careful. Sometimes we do a big, long expression and our calculator reads it differently than we intended it to. I'll give you guys some examples of that later. But like if we're taking an average and we add 5 numbers and divide by 5, if we don't put adding the 5 numbers in parentheses in our calculator, it's going to do the last number divided by 5 and then add all the other 4 numbers to that, which is not going to give us the average. I can show you what I mean when we get to class. Example 2, I have 0.5 plus 0.5 divided by 0.5 minus 0.5 times 0.5. So a bunch of the same numbers. I got to do division and multiplication before I add or subtract. So 0.5 divided by 0.5 is just 1. Any number divided by itself is 1. 0.5 times 0.5 is 0.25. Okay, so I have 0.5 plus 1 minus 0.25. I perform that. It's addition and subtraction, so just work left to right. I get 1.25. Okay, this we could use distribution, which we'll talk about down the road, so I don't really want to get into that. Since we have 2 numbers in here, we would do the addition first because it's in the parentheses, or group symbols. So 8 plus 6 is 14. 2 outside of this number means multiplication. So if you ever see 2 numbers in parentheses next to each other, a number next to a number in parentheses, it's multiplication. So it may not have one of the symbols we've used, but we know it's multiplication. So 2 times 4 is 28. Okay, we'll go over these practice set problems as a class. All right, and then the last one we'll be covering this week is using cross products to solve proportions, just like we talked about earlier in the video. Okay, we have 3/4 is equal to 6/8. That was the example we looked at at the start of the video. Okay. We can use cross products to make sure that they're equal. So if I have 1/2 equals 2/4, this is a pretty simple example, but it'll get the point across. So cross product, well, 1 times 4 is 4. 2 times 2 is 4. So the cross products are equal. So I know that these fractions or these ratios or whatever are equal. Okay, they're proportional. Now let's say I did something and I wanted to see if they were equal. I wanted to test. Oh, well, 3 times 3 is 9. 1 times 10 is 10. Well, those are not equal, so these fractions are not equal. So we can use cross products to see if something is equal or not. That's where cross multiplication and division comes in down the road when we have an unknown. So 3/5 and 4/7, are they equal? 3 times 7 is 21. 5 times 4 is 20. Those 2 numbers are not equal. They're close, but they're not equal. And then when we find cross products of 2 fractions, we're simply renaming the fractions with common denominators. The common denominator is the product of the 2 denominators, and it's usually not written. Look again at the 2 fractions we compare, 3/5 and 4/7. So 3/5 times 7/7 is 21. 35. 4/7 times 5/5 is 20/35. Okay, so if we got these fractions over common denominators, that's another way we can see if they're equal. Probably easier to just do your cross products and see, but Obviously 21/35 and 20/35 are very, very close, but they are not equal. 8 and 12 and 12 and 18 do these ratios. 8 times 18 is 144. 12 times 12 is 144. So they are proportional. Now, this is where we talked about, well, we have an unknown. We got to find something that's equal to 6/9, and it's 10 over m. So what we're going to do, okay, so we're told they're equal. So we know that this fraction reduced would have to equal this fraction reduced. They're equal. So we do cross multiplication, the cross product. So 6 times m, we just write 6m. 9 times 10 is 90. So we cross multiply, then divide. And we get 90 divided by 6, which gives us 15. So 10 over 15 equals 6 over 9. So as I said, using the method earlier, what was our example? Oh, 3/4 and 6/8. We multiplied 3/4 by 2 over 2 to get 6 over 8. Yeah, sometimes it's easy to say, well, 6 times what number equals 10? We could go in and figure that out, and then we multiply 9 by that same number, but it's not a whole number, so it's going to be a little bit trickier. That's where I said cross multiplication and division, I think, is always going to be the best bet, just because it works out no matter what, versus trying to find out, well, not 6 times 2, not 6 times 1, obviously 6 times maybe 1.5. No, that would be 9. 6 times 1.6. Going in, it's just going to take a little bit longer. Whereas if we cross multiply and divide, we're going to get it right away. So 15 over 21 equals W over 70. And we cross multiply. 15 times 70 equals 21 times W. Then we multiply both, or multiply 15 times 70 and then divide by 21. Cross multiply, then divide. W, our unknown, equals 50. We'll do this practice set together in class. That's all we have for this week, those 3 lessons. So we'll see you guys in class.